Hello everybody, today we're going to be discussing and having a little demo on the safe use and principles of electrosurgery and energy devices. I would like to obviously at the outset thank Aga Khan University Hospital, which is where I am an operating faculty, for having me and providing me with all the equipment and the space to have this demo done. Thank you very much, Aga Khan Hospital, University Hospital. We have to understand a few things about electricity before we go on. Those are the principles. One of the principles of electricity is it is an energy which will always find its way back to Earth. So there is always a grounding that is required. If that is not complete, then that will be an incomplete circuit. The second thing that is important is for us to understand that electricity will find the path of least resistance back to its way of Earth. So it means those are the two things we have to understand. A few other things we have to probably understand, and why we may need to understand this is the mere fact that surgery nowadays is not complete usually without electricity. So the use of electricity in our surgery is very important. But it's very important to understand that the use of electricity should be done safely. So there are two aspects of electricity use in surgery. That is electrosurgery. Number one is you need the skills to be a good surgeon. Number two, you need the knowledge to be a good surgeon. Without any of them, you will probably be incomplete. So without skills, you may probably not do a complete surgery and end up with complications due to that. Without knowledge, however, you may do wrong type of surgery. So without proper knowledge of electrosurgery unit, you are likely to be doing an incomplete surgery. When we ask this question, how many of you use electrosurgery? Everybody put their hands up. How many of you know how to use the electrosurgery safely? That is a problem. How many of you may have seen accidents that have happened due to electrosurgery? Many of you would say yes. We have seen burns, we have seen damage, we have seen areas of injury where they were not supposed to be. So these principles are going to be clearing your basis about electrosurgery. So a few things to understand. There is what is called the electrosurgical circuit. So this machine here is called an electrosurgical generator. We have different companies. This one is from Valley Lab, from Medtronic Meridian, and we have Irby, we have the ones from Crown Stores, we have the ones from Olympus, we have so many different varieties and locally made as well. So what is this electrosurgical unit or ESU or generator do? This is the electricity that we have called the household electricity. This household electricity has 240 volts and 50 to 60 hertz frequency, so 50 to 60 cycles in a second. So this electricity is something that you and I will not have the courage to put a finger in. Why? Because you get a shock. So what is a shock? A shock is the Faradic effects that you see, or the neuromuscular stimulation that you see. So when you do that with a frequency of 60 hertz, you get a neuromuscular stimulation, which if not taken care of immediately can even cause other dangers like including death or convulsions. So this electricity is connected to this ESU. The generator's job is to change that low frequency to a high frequency or radio frequency alternating current. So this is also alternating current, this is also alternating current. This is not electrocautery. Electrocautery or cautery is a wrong terminology. We'll discuss that in the presentation. So this is electrosurgery, where we are using electrons with its mobilization and vibrations going from one place to the other and creating heat. So this low frequency is changed into a high frequency or radio frequency alternating current. A frequency above 100 kilohertz, so that is 60 hertz. But above 100 kilohertz, the neuromuscular stimulation is lost. Above 500 kilohertz, it becomes almost radio frequency to 3 megahertz. So this is usually between 500 kilohertz to 3.3 megahertz. And in that frequency, you do not get electrical current as a shock, but you get it converting to heat energy, and that is what we use to advantage. So when it comes out this side, it is now a radio frequency or high frequency alternating current. So this, we need to understand two circuits here. So we have a circuit here called bipolar and monopolar in this machine. In monopolar we have cut and quag. This cut and quag is not the effects cut and quag. So I'm going to make you understand two things. Please understand the physics part of it, which is the engineer's language, and the biology part of it, which is the doctor's language. Do not mix the two. So this here is the physics language or the electrical engineer's language. There is a cut mode and a coagulation mode, which is dependent on the circuit and the type of electrical current that goes on. So in the cut mode, it's a low current, high frequency, undampened current, which is a continuous current. So that is what you need to understand. So low frequency, low current. So it's a low current, both of this and this. Whereas the quag part is a very high voltage. So this is low voltage, this is high voltage. Quag current is the high voltage. So the low voltage is safe for us, whereas the high voltage is very dangerous. It can go up to 5,000 volts. So this is 240 volts, this is low voltage, this is high voltage. They are both, the quag part of it, the extreme end of it, is going to be active only for around 4 to 6% of the time that you press the button, the blue button. Whereas the cut mode is when you activate it, it activates almost 96 to 100% of the cycle, which means the current is going through almost throughout. Whereas this one is a very high voltage, no passing, very high voltage, no passing, very high voltage, no passing. So that is the electrical part of it, and it's the electrical engineer's language of cut and quag. It does not mean that cut cuts and quag quags. That is what we need to understand. So for our medical or biology part of it, what we are going to understand, for today's lesson, we are not going to use the word cut and quag as the effect. We are going to use vaporize, and we are going to use desiccate. So for us to understand, desiccate means dry up or coagulate for our understanding. Vaporization is it's turning the intracellular component into immediate steam, and it will cause a burst of the cell, which you see as a cut of effect. So we're going to remember that. Then we will go into what these means: the pure, the blend 1, blend 2, and then there is the quag mode. And in the quag mode, there is desiccate, fulgurate, and spray. We'll have to go into those individually. Now let's go into the circuit. So when we go into the circuit, the monopolar circuit is when, this is the monopolar part of it, is when you have the output from the ESU into the instrument. This is, let's say, our patient. This is a return electrode which takes it back to the machine to complete a circuit. If there is a break anywhere in this circuit, then this will not turn green, it will turn red and beep, telling us that there is a problem. So this is with the newer machines. In the past, these return electrodes are of different types. We have the metallic one, we have the silicone one, which is a black rubber, and we have these ones which are dispersive, and they have an automated monitoring telling us whether it's a complete circuit or not. So let's activate this and see. For demonstration purposes, I've used a higher one because we have to see what's happening. So when you activate it, you can see that it's actually working, and to complete a circuit, this is causing a cut. I can now cut. The electricity goes back from here and into that. So I can also show you that was direct. Now what will happen when I activate it in air? See, there is activation going on in my hand. I am not getting burnt. Now we'll have to discuss why that is happening. I'm not insulated, I'm not wearing gloves, but I am seeing, and it's a very high, the frequency, but I am not getting burnt. Now when I activate it on this, see, there you can see that it is activating. So I activate it, and there it's activating and burning the patient where we want. The same thing when I use the blue, the coag, it still does the same thing. The difference is one is very high voltage, one is low voltage. So we have to understand one thing. When you get a thin in, why is this not burning? When you get a thin in, this is density. So you're having a thin in and you're getting an effect of a cut. But you have a broad surface taking the electricity out. You cannot convert it. But what's happening, the same amount of electricity going in here to cause this is coming out through here and returning. Now we have to understand one thing to see the difference that will be seen in this. Now look at this return. I am going to cause a burning here. Can you see? It's very high. So you can see what happens. You can actually see that it is burning on the surface here. What on the other hand happens on the other one? Look here. Alright, so look closely, guys. If you look closely, you will see that it actually, if you see here closely, so can you see that? So what is happening? You're seeing burning on the bottom. So instead of burning on the top, I have burnt on the bottom. Can you see the difference? Now, this is a burn caused by me activating here. So what principle am I trying to show you? I'm trying to show you that the density is very important in deciding what happens. And that will help us understand about safety. So, please remember, thin in and broad out through the return, broad out, causes burn where there is a thin in. So a thin in, burn, broad out, no burn. Thin in, thin out. Thin in, thin out. Burn at the thin out. So please understand one principle here, that when you want to place this return electrode and when you are doing surgery, please understand that monopolar, whenever it gets concentrated into a thin spot, will cause a burn there. Now that is practical in 2-3 areas. Number one, where you apply the return electrode. Number two, where you're operating. So for example, there is a band of adhesion that is attached to the surface, to the abdominal wall. So that band of adhesion may be a thin strip of band, but the band is now touching a bowel loop down there. So what will happen when you activate this? The electricity has to find a way back to the return electrode. whichever maybe wherever we'll put, so we'll demonstrate. But as it finds its way out there, when it reaches a thin spot, it hits up there. So if that thin strand is attached or hooked onto, let's say there's a band this way and the thin strand is attached to bowel and the bowel loop is lying on it, it will hit here. So you're burning here, but it will hit here. And it will cause a burn on a bowel loop that was way away from your site of operation, making it very dangerous. So that is very important to understand. Number two, what I was doing with the different surfaces, if you see before I remove this, so you can see this is now cut. There is what is called, you know, the non-contact. So for cutting, if you want to cut a tissue, you activate, close and go close and make a cut. So it makes a cut like a fine knife. When you do the same with coag, it is very high, remember? So you're going to activate it and see, you're going to still cut. But what is the difference between these two cuts? The difference would be in the damage to the surrounding tissues. So if you use the cutting mode, it will have less damage to the surrounding tissues because it's low. Secondly, it will not cause too much of damage. Another important application is, for example, when you are doing a surgery and you have held vessels. So when you have held the vessels and you want to buzz the vessels because you want to stop the bleeders, what is the normal way we would do it? We would do, if you ask most people, they would say I would use coag to coagulate and I would use cut for something else. Well, that's wrong use of electrosurgery. That's what I was trying to tell you. The correct way of electrosurgical use would be to use the yellow as a hemostat, that way. So you've held a vessel and then you would use the yellow and activate. What difference does it make? When you're using the blue, it is very high voltage, so it's very dangerous, as we have discussed. So what will happen here? There will be many of you who would say, maybe by a show of hands we can check, who would say that when they were operating once and they were buzzing vessels like that, they suddenly got a shock or a burn. Then when they looked up and found out, they removed the glove and they realized there is a hole in the glove. Do you think that hole was already there? No. That hole was created by this high voltage current that you used, which tried to find a way out through you. Now that will never happen when you use the yellow for the buzzing. So one of the hints, please use yellow cut mode to coagulate or desiccate the vessels that you've had. Do not use the blue. The blue is used for something very different, which we can discuss. Second thing we have to understand is the density. So I told you this spatula, we can use it to cut, I can use it to dry. So this is now I'm using it to desiccate. So if I just change the surface using the same mode, I have different effects that I get. So I can get a cut, I can get a desiccate. The same with the blue, I can get a cut, I can get a dry. So where would I use these differences is what we have to understand. So when we come to pure cut, it means it is 100% undampened and it is active, continuous during the whole cycle of pressing the button. When I go to blend, so let's go to the other side, we say the coag, it is active only 4 to 6%, but it's very high voltage. In that you have desiccate, you have fulgurate, so this is fulgurate and this is spray. See the difference? So you can hear there is a different sound and it's spraying the over superficially. Whereas when I go desiccate, it will not do that. It is now drying it up. So there is a difference in the effects that we see by this. So fulgurate, spray. So where would you use fulgurate? If you have a raw surface that actually is oozing, let's say on the uterus, on the liver, then you would use a fulgurate or a spray to spread the superficial burning, and you can use the blue directly with a direct instrument because you want to cause a superficial surface oven burning. So it doesn't go deep, but it burns the superficial area very quickly, and that will stop the oozing. But when you want to hold vessels and burn vessels, and you have to be very careful, use the cut mode, the yellow, do not use the blue. Very important. When we now understand about the blend is in between in terms of the dampening, the damp cycle, the duty cycle. So the duty cycle in cut is almost 96 to 100%. The duty cycle in the coag is 4 to 6%. The duty cycle in the blend is a mix in between. So there's blend 1, blend 2, and then let's say blend 3 in some machines. So depending on how much duty cycle is, it will vary the blending. So where will you use blend? Blend can be used in situations where you want to cut nicely, not cause too much of charring or carbonization, but you also want no oozing or no bleeding. So for example, in leads of the cervix, the large loop excision of the transformation zone or the conization, you would use blend on the loop. So if you use pure cut, it will cut like a knife, but the whole area will start oozing. If you use the coag mode, it will stick to the tissue and not cut through, causing too much of carbonization and burning. So you use a blend which helps you cut and not ooze. So that is blend. So there are places where you would use blend, there are places where you would use cut, there are places where you would use coag. When you are trying to open the abdomen for surgeons, you've made the initial incision with a knife, and now you're cutting the subcutaneous tissue with electrosurgery. You do not use the coag because that is too much. It's not going to be, it's too high a voltage. It is risky. You can use a blend. So blend will cut smoothly, will not allow too much of oozing. You can't use pure cut directly on that situation because it will cut the fat tissue very smooth like a knife, but it will start oozing everywhere. So this is where you would use blend again. So there is a rules for each of these to cause different effects. So let's not mix the physics of these normals and use the misnomer to understand the biology of the effects that we want. They are not the same thing.